that same way. We divide that growth that happens inside the womb a little differently for the baby. So we start out by talking just for the first 2 weeks about the germinal period. So germ, something that can grow. The germinal period, something that's growing and moving. But in the germinal period, the first 2 weeks, that's what we mean by germ, this egg hasn't yet implanted in the uterus. So likely what happened is this mother had just ovulated. She's not expecting her period for another 2 weeks, but the egg has become fertilized. And all that time, those 2 weeks, while the egg is fertilized and traveling through the fallopian tubes to get to the uterus, this is what we're talking about here. So this little tiny egg, we call a zygote, hasn't yet taken any nutrients from the mother. It's just gotten its genetic code. If the mother does something she shouldn't during this time, before she knows she's pregnant, she smokes a lot of cigarettes or drinks alcohol or something like that, it's not going to affect the baby at this stage, first 2 weeks. The next stage is the embryonic period, 2 to 8 weeks. And as you can see from the definition, it's an organism in its early stages of development. It's not yet recognizable as human. It looks more like a fish. We'll look at pictures in a minute. But this is a very important period. If a pregnancy is going to be lost, it's likely to happen during this phase, most likely. And then the fetal period is the whole rest of the pregnancy. So you can see it's very different from the mother's experience. And it just means the fetus is just the unborn young, but it sort of looks like a human being rather than a fish. Okay, so starting out with that first 2 weeks before she knows she's pregnant, we call the little developing organism a zygote at that stage. Maybe that word sounds familiar to you. We talked about monozygotic and dizygotic twins. That's where that ZYGOT comes from, the zygote, which is what we call this fertilized egg where the cells are starting to divide. This is what we're looking at, the first developing cells. And we only call it a zygote during those first 5 days. So it's when the egg gets fertilized. The first division, the first cell division, once it gets fertilized, which happens within a day or two after fertilization. And then that period while it's traveling through the fallopian tubes. So just 5 days about. After that, on day 6, mama still doesn't know she's pregnant probably, 6 to 14 days, we call it a blastocyst. And that means, this first word is very important. That means that the first differentiation has occurred. Differentiation means that the cells now have specific purposes. In the zygotic state, these cells could turn into anything. They could turn into neurons, they could turn into skin, they could turn into fingernails, they could turn into the placenta. They could turn into anything. We sometimes call them stem cells. But once they're differentiated, they can't become anything anymore. And the first distinction is the differentiation into what will become the placenta. And the placenta is the tissue inside the uterus through which the baby is going to get nutrients from its mother. We'll see pictures later. And the rest of it is going to be the eventual human being. So that's the first differentiation where the cells have their own purposes. And also during the blastocyst stage, we have implantation. And all that means is that it's lodged itself into that nice blood-filled surface of the uterus, and now it's in there, starting to receive nutrients and other things from the mother. Okay. At this stage, it's estimated that about 50% of pregnancies are lost right here. If it's not working, if the cells aren't dividing right, if something goes wrong, this egg is just going to flow out and she'll never know that she had a fertilized egg. Okay. So next we move into the embryo stage, which, as you'll recall, goes from that first 2 weeks, until about 8 weeks. And it begins, its beginning is marked by 2 things. First is implantation. The egg is implanted in the lining. And the second is differentiation within the future human being, right? That differentiation is when the blastocyst previously divides into 3 layers. The endoderm, this is not on the test, good to know, becomes the future internal organs. See it here in this little image. The mesoderm, and we're talking about lungs, thyroid cells, the mesoderm in the middle, the skeleton, red blood cells, kind of in the middle, not the organs. And then the ectoderm on the outside, the skin, also the brain, pigment in the skin, things like that. So that marks the beginning of the embryonic stage, and this stage is extremely important. I'm not going to cover this. I looked at this during break, and I'm not going to cover it just because of time. The embryonic period is an essential period for development. First off, because of organogenesis, genesis meaning beginnings. The beginning of every essential organism in the human being happens during this embryonic stage. It's not fully developed, but it begins, like the heart, the lungs, every organ that's going to eventually be inside the body and critical for development is starting during this embryonic stage. Secondly, this word proliferation means that like the cells are being born, they're dividing and creating new cells. And they migrate to where they need to be. This happens in the body, it also happens in the brain, and we'll talk more about that and hopefully watch a tiny little video clip of it later. Differentiation. The cells that are going to be the heart become heart cells. The cells that are going to become the pancreas become pancreas cells. This differentiation is continuing. So the cells proliferate, they divide, they go to where they need to go, and then they turn into what they need to become. The neural tube, that's what was talked about on the previous slide. It's the tube that is eventually going to form the brain and spinal cord, where all the neurons are going to be residing. The neurons all begin here. Something goes wrong with that, then we have spina bifida, which is what we were talking about on the previous slide. That's not relevant. And then the body begins to take shape. Remember, the end of the embryonic stage, the body looks like a little human being. Week 3, the heart starts beating. We get the start of arm and legs, the outline of the eyes and ears. And by week 8, it's 1.5 inches long. I mean, still pretty teeny, right? Tiny, tiny, but recognizable perhaps. And about 20% of pregnancies are thought to be lost during this embryonic period. Like if something goes wrong, the heart just doesn't form right, it's not going to beat right, that little embryo is going to be lost. Just a little bit, because I saw this in your book, the development happens. It's called cephalocaudal. It just means the development up here happens before the lower extremities. And also proximal distal, proximo meaning near the torso region, the center before the arms before the fingers, the legs before the toes, and so forth. That's all. I saw these in your book, so I wanted to mention. So this is a weird chart, but let's take a look at it anyhow. It's weird because of the way it's organized in terms of time. If you look at the tiny print, you'll see this is 1 day, 3 days, 4 days, 17 days. It's really uneven. So that's why I added these little pointing out things, that this right here is right around the end of the germinal stage. Right, the embryonic stage is beginning here. We've had that differentiation into those 3 layers. Of course, this is implanted by now. And then look at where the embryonic stage ends. So you see, we're still talking about days here. So this is that 1.5 inch long little embryo that's implanted and growing through the cord. And then all of the rest of this, which really encompasses the bulk of the pregnancy, is all the fetal period. when that being is growing, continuing to differentiate, cells are continuing to grow, the brain is going through a lot of development. All this is during the fetal stage. All right, let's just skip that for now. This is going to be a really weird one, you guys. The sex hormones as prenatal organizers. I'm just going to cover it one time and I don't have anything else on it. Okay, but we can talk about it more if you want to. So we already know that the male genotype has an X chromosome from mom and a Y chromosome from dad, right? You guys remember that? Okay, we know that the female genotype has XX. Does that automatically mean that the organism is going to be male or female? Yeah, the answer is no. Okay. So all of this happens, by the way, the maleness or femaleness of the future human being, it happens during this embryonic stage. So what I'm describing here is happening right here. And the gonads, the reproductive organs, have potential to be male, drop down and become testes, or female, become ovaries. So either way, the potential exists. So what causes them to either become testes or ovaries? Well, by default, every single one of them is going to be female. In every instance, the future gonads are going to become ovaries. But remember that tiny little Y chromosome. Remember the Y chromosome is small, about 30 genes. The X is big. Here's Y, here's X. The X has a lot of information. We talked about how that in some ways makes males vulnerable. But this Y chromosome serves one important purpose. It dictates the release of androgens, specifically to testosterone. And it is those androgens at a critical period at a certain point in time, around 8 weeks of pregnancy, it's those androgens that impact the gonads and cause them to migrate down and become testes instead of ovaries, right? So this has sort of interesting implications. Because it means that if something goes wrong in that Y chromosome and the testosterone doesn't wash over the future gonads, then we have an XY individual that might be kind of in the middle, androgynous. Decades ago, I had a student in my class who was androgynous. That means that her reproductive material, she probably could, but it had both male and female characteristics. And her parents kind of raised her as a girl. They named her Nikki, but they had to let her decide which way she wanted to go. I think she stayed with her female, but I mean, her body was literally, you know, male and female kind of a mix. She could never mature without added hormones. She couldn't develop into a mature. She probably still couldn't reproduce. Maybe something went wrong. I don't know. I think she was XX, but I'm not sure. But maybe something went wrong. Right? This was that release of testosterone. Or what if you have an XX, and have you ever seen those commercials, those low T commercials? For men who are low in testosterone as they get older, like, are you having trouble feeling energy? Are you not attracted to your spouse? You know, like that. You might have low T. And then they have like a deodorant even. That is testosterone. And let's imagine the spouse starts using that deodorant every day, doesn't realize. Infuses testosterone in her body when she's carrying an embryo. What happens? Do we have that in-between state or potentially an XX individual who develops as male? So I thought this is interesting. I don't believe your book talked about it, but I think it's really interesting and important, especially in this time when people are talking very much about sex. Yeah. Go ahead.
Would that count as a teratogen or not?
No. Yeah, teratogen is anything that can harm a development. I guess it depends on whether you think that
that would be harm.
That would be harm. I mean, I would have to say I would say yes. because probably that individual will never be able to reproduce. Probably that individual might have challenges in school. I'd say yes, it has in fact caused harm. And then we have to think too about, say, hormones that we're giving to animals. Okay. Things like that. All of that stuff can have an impact and, maybe even contribute, because those hormones, once the testosterone is produced, it also shapes the development of that baby's brain. It happens big time prenatally. Testosterone has an impact just after birth for males, and it also has an impact again when puberty, at the time of puberty, shaping the brain to have more male typical characteristics in terms of the thought process. Did you have a comment?
I was just gonna say, one of my instructors, biology instructor here at DC, he said that, for men not to hold on to receipts too much, but something about it affects, there's something in the print that's like, estrogen, something it affects the hormones of a man, and not to hold on to receipts. And I always remember, like, I don't know, kind of misremembering, but something to do with, don't hold on to the receipts. It can bother the male. The balance.
Or the hormone.
Yeah.
No, I have not ever heard that one,
Yeah.
but there are a lot of things in our environment that may in fact affect the hormones. I mean, we've really done quite a number on artificial. The world around us is no longer consisting of its natural. It's really quite more so. All right, this stuff is covered. You can see it very often, just a little bit in the fetal period. You'll read this in your book as well. You can see these tiny little feet at week 10. Usually the baby is covered with this lanugo, which is really fine hair that some babies are born with. In fact, it depends on how much they are. Their whole bodies can have that as well. Their bones start to harden, sucking motions, quickening around 20 weeks, week 19, 20, and that's the term for when the mother first can feel the baby moving. Probably other people won't be able to feel it from the outside yet. Startle reflex, if a big loud thing happens, the mom will feel the baby startling as well. The alveoli, we'll look at an image in the next, if we have time. But the air sacs form in the lungs, very important, because premature babies, that's where things go wrong for them. The air sacs aren't mature. Fingerprints already, better not commit a crime. We already have you identified. And at week 24 is what, according to your textbook, which I do trust to be accurate, is the age of viability. I have more detail on another slide, but in a nutshell, that's the age at which, if it were born, we could probably help it survive. All right, and then you can see the continuing just images of what can happen at all these different stages. And if you're ever pregnant, it can be really fun to look at this and imagine it. I know my daughter, I felt she was really so good at getting to know her baby when she was pregnant. That wasn't something I thought about much, but she really did take time to become aware of what was making her baby more stimulated and what wasn't. And I thought that awareness was really lovely in her. Brain development. So just a little bit, all this is right here is a little review of what neurons are. So the neurons are the cells in our brain and our central nervous system. And they're kind of cool, you guys, because unlike all the other cells in our body, they live with us from before we're born. I mean, in rare cases, we can have neurogenesis in the hippocampus. Neurogenesis meaning the birth of new neurons. But typically, no. So the neurons that are in there making you do what you need to do have been with you since before you were born. And they connect up depending on what you ask of them. So if you're taking stats right now and you're working really hard with the mathematical side of your brain and you're really working at it, your brain is developing new neural pathways, connecting up with other neurons, growing new dendrites, helping you. So it's really dynamic. And that's all this says. I also mentioned these glial cells. If we watch this little video, and if I have it in the right place, I didn't have time to preview again. If it's in the right place, the glial cells are what actually help the neurons to migrate where they need to go in the developing fetal brain. So what is happening prenatally? So the first 7 weeks, so we're talking about the zygote, the germinal and the embryonic stage, we have proliferation. And once again, that's cell division. New neurons are being born, in other words. After that, weeks 8 to 15, so we're not quite halfway, the woman's not quite halfway through a pregnancy. That period is dominated by migration. So these glial cells in the brain, which are like support cells, they are taking the neurons to where they need to be in order to function as the right part of the brain. And then we have differentiation happening at the end. Once they get to where they need to go, you know, you're part of the frontal cortex, right? This one's part of the amygdala. Once they get to where they need to go, they need to differentiate so they can develop as they need to develop to help the baby in all its functions it needs. Now, I have a video that, as I mentioned, I didn't have time to preview. Again, I've showed it before, but I didn't write down everywhere where I should show, but I believe I found the place. And so this is an excellent video, The Secret Life of the Brain. And we're just going to play a couple minutes of it. I believe I have the place where they're showing this migration of neurons. This is inside the fetus's brain. So the neurons are sending signals. I think there should be some audio. Unless I have a weird one like we had last time. What they're showing are these neurons connecting up. These long stringy things are dendrites, and they're starting to connect up as the baby places demands on it. This may be another weird, I actually had video when I was just previewing it, but I think I won't show it because I think maybe it's one that isn't supposed to be on YouTube, so I think I might have to go to the original source. It's okay. That's I've described to you what happened. Does that make sense what I was describing in terms of brain development? Okay. So just a little bit about the birth process, and then we'll go into teratologens. So in the birth process, a shift in the hormones dictates what's going to happen. Sometimes the amniotic sac will break and the water will leak out, and then at that point the baby's ready to be born. Otherwise, naturally produced hormones begin the process of contraction, and the purpose of the contractions is to open up the cervix so the baby can come out, and also later when there's need to actually push the baby out. So you can see that we usually divide labor into 3 stages, and the first stage is what they call dilation. And so you can see here the cervix, that's what used to be plugged with mucus. Well, this needs to open, and it needs to open about 10 centimeters to allow the baby's head through. And that's what all those contractions are doing. They're forcing that opening. And this is usually the long part of labor, the part where the woman says, what was I thinking when I decided to have a baby? Goodness gracious. Right. I put sometimes hormones news because increasingly, if a woman's water breaks, there's a risk of infection to the baby. So in that case, they would want to induce labor. They would do it artificially with hormones. Some women now induce labor on a prescribed date ahead of time. You know, they say, well, let's have the baby on this date and it'll be convenient for me and for the doctor. And so they induce the labor for that reason. And it's done not uncommonly these days. And I did not look up the research on the outcomes, so I won't speak to it. Then comes delivery, the second stage. Head comes out first, ideally. You know, usually this pushing that the mother has to do takes about an hour for the first pregnancy. It can also go very fast. Usually the mother is discouraged from pushing until she's fully dilated because there can be tears or damage to her body if she pushes too soon. And then stage 3 is the delivery of the placenta. So presumably maybe mom already has that baby in her arms or has seen the baby. And the placenta is, remember, that tissue that allows the nutrients to get to the developing fetus. And it's very fast. And the cord also comes out at that time. The cord is through the mechanism through which it gets nutrients during the pregnancy. Those Braxton Hicks contractions are contractions that are like preparing the body for the real thing. But if a woman goes to the hospital or calls the midwife or whatever she's doing with those, it's not time yet for the baby. I talked a little bit about induced birth, but we won't talk about that now. And we won't talk about, actually, we will talk about all this briefly. Maternal mortality rate. This used to be the most common cause of death for women, dying during childbirth. And the practices that we've had starting in the 1950s and onward have really reduced that. So now we know, now we have a cesarean section to remove a baby if the mother's in trouble. We know how to use sterile, we don't cause infection in the mother. We have a lot of good practices. But look at this, mortality rate, women dying. Of developed countries, our rate is one of the worst. And in this country, it's due to some of the disparity that we have between rich people who have a lot and people who have a little. And the lack of medical access for people who don't have very much. So we still aren't doing very well here in the US. And you can see that Native American people struggle with this as well. So just so that you're aware of the things that really make a difference, prenatal vitamins. Someone doesn't go to a doctor early in pregnancy, they won't get those very important vitamins. Folic acid, if a woman doesn't have enough folic acid in her diet before she gets pregnant, her baby can be born with spina bifida. Spina bifida, where the neural tube doesn't close, often resulting, say, in movement disorders or even anencephaly, where the brain doesn't develop at all, or hydrocephaly, where the brain can discard the cerebral spinal fluid and it swells the brain. Serious consequences, nutrients, right? Getting those nutrients, getting the prenatal vitamin, getting care, watching out for some of the worrisome conditions like preeclampsia. Prenatal care, very important and often not accessible to everybody equally. I introduced the terms late. Here's the placenta in a healthy pregnancy. You can see, it delivers nutrients through the cord, and it can also deliver toxins and things that aren't helpful. I'm going to just skip through this. Okay, a couple things about problems during delivery. Two that we'll talk about. The first is breech. The baby has to be head down for a reasonable delivery. The head is nice and solid and firm. The bones in the baby's head can compress. There's a soft spot you've heard about, so that they can just compress a little bit to allow it to get through the cervix and the vaginal canal. The butt, in the case of a breech presentation, doesn't have that firmness. This is a difficult delivery. This mom is going to have to push the hips of this baby out, and there's not much to help. There's no nice firm head. This will be a difficult delivery. Or what about this one? The transverse breech, where the baby is sideways. Really tough to deliver something like this. And this is the kind of thing that might have caused a mother to die during childbirth. The second thing, problems during birth at the perinatal time, is placental previa. So the placenta can slip. This is impacted by things like smoking. So the placenta can slip down. It can just be lying low. That can be a problem, but can actually slip down to where it's partially covering or covering the cervical opening. This is a difficult delivery. And so what we do about that nowadays is we have what's called a cesarean section. And it just means that there's a cut down low on the abdomen, and that baby is delivered by the doctor surgically. And she might be awake during the surgery, but she might be numbed so that she's not feeling anything like that. The baby doesn't have to go through the stress of delivery. You might think that's completely a good thing, but not necessarily so, because the stress of delivery can stimulate that baby to cry and become active and engage in the world. And then a tiny bit about pain relief. I was there for both of my granddaughter's birth. First one, my daughter had it naturally. The second one, she decided to try an epidural. An epidural blocks all sensation. It's inserted into the spinal cord and it blocks all sensation. I thought it was a really different experience because it was as if she had a baby without any pain. It was, to me, it seemed kind of bizarre when I was in the room with her comparing the first with the second one, but it's not harmful. And it seems to really help with pain. And if it's a long, difficult delivery, this can really allow the mother the strength to persist. And what's really taught quite a lot that can be very helpful is called the Lamaze technique. It's something that's intentionally taught, like both parents would probably go to a Lamaze class during the pregnancy, and they would both learn how to work with the delivery. So helping with slowing the breath, maybe some massage, and relaxation techniques, all of which can help the mama when she's giving delivery. And I just mentioned this because it's in the book. As soon as a baby's born, they look for these 5 things: initialized